name is Matthew Khouzam. I'm going to be presenting AI-powered trace analysis, adding MCPs to TMLL. And this is a talk aimed for those that are AI adjacent and that potentially have tools that they want to bring into the AI sphere. But it's also a bit of a war story, so I hope you enjoy. So let's start off. Here's the agenda of what I'm going to be talking about. I'm going to set the context on tracing. It's a very interesting domain, and I'm not just saying it because I've been working in it for a long time. Then after that, I'm going to be explaining MCP, and we'll walk through an implementation step by step, show the debugging tools, and I'll show off the results at the end across multiple AI clients. So before getting too deep into it, a quick background. My name is Matthew. I've been working in open source for over 16 years, mostly in tracing and observability, and I work closely with universities. I am a former board member and for the Eclipse Foundation, and I also have the privilege of being paid by Ericsson to make the world a better place through open source, and for that I am eternally grateful. So next up, before getting into MCP and how to connect your application to AI, I want to discuss tracing and Trace Compass and why do we want to add AI to it? Because we don't want to just do it because it's cool. You need a business case. Tracing captures what actually happened in your system. It's nanosecond granularity in a machine-readable way. Unlike logging, it's designed for minimal impact to the system and minimal overhead. There is a downside. It produces enormous volumes of data, and they're hard to analyze manually. So Eclipse Trace Compass could be seen as the Swiss Army knife of trace analysis. It can handle kernel traces, user space traces, network traces, stitch them all together, put them across a whole system, a whole cloud, and trace the cloud. And it's very powerful, but because of that, the learning curve is incredibly steep sometimes. You need to know which views to open. You need to know how to interpret the data. One of the most brilliant men I know yesterday stated, I just implemented the tool. I don't know how to view the traces in them. So why add MCP? I'm going to give my personal motivation. I have spent 16 years building these tracing tools and using them. And I watch users struggle. And they're struggling where I see that it's very easy to get to the next step. The MCP lets users put natural language interface on top of your tool. So instead of teaching someone the tool itself, you have the tool adapt to the person. I think this is a much more natural and human way to compute. So before getting a little further into this, Trace Compass has 11.3 release that is coming out, and we're on the road for 12. And the new big feature is partial CTF2 support. Now, CTF2 is the common trace format. It's the standard format for LTNG and OS level traces, as well as user space level traces. It's binary, compact, efficient. And the new one is the same, but with JSON metadata and handling of many new features such as binary blobs and compression in the trace. It's very exciting, especially if you get down to the bit level. And on top of this, we have a library called TMLL. Now, the TMLL, or Trace Server Protocol Machine Learning Library, wraps machine learning techniques into a clean Python API, and it talks to the trace server, which is a library that is the backend for Trace Compass, and makes the data AI accessible. Until now, users need to write Python code to use it, or Jupyter notebooks. And this is a gap that MCP is filling. So what is MCP? It's an open protocol. It was developed by Anthropic. It standardizes LLM interactions with external tools. They advertise it as the USB for AI, one connector for every device. And what I would say is that it's very much the USB-C of AI, where it's mostly one connector for every device, but you have to have a few little points of caution. Fun note, it was released in November 2024, And I believe Eclipse Theia supported in December, or the first week of December 2024. So the Eclipse ecosystem knows MCP well, and there's a lot of expertise around here. So in a nutshell, MCP is something where your AI receives tool schemas, and it decides autonomously which tools to call. And the protocol handles the plumbing, the AI handles the reasoning. So with this, we can keep it very simple for the user. Why would it matter for you? And I'm going to give you the practical pitch. You can give to your managers if you want to try this out. Why should you care about it? The AI picks the right tools and parameters. So the actual computation is in your deterministic code. And I'm an engineer. I don't like non-deterministic. I really like it when I give the same input and I get the same output. So this will reduce the amount of hallucinations, and more on that later. Without the MCP, you'd have to paste trace data into a prompt and ask the LM to analyze it. Now, traces are big. I don't know if you've ever tried pasting 1 megabyte into ChatGPT. Well, traces are 1 gigabyte to 1 terabyte. So you would be running out of tokens very fast. You don't need to rewrite everything also, and that is very fun. You just wrap, I'm going to be showing a workflow where you wrap an existing CLI as an MCP server, and this will allow you to make not only your tool work with a CLI, but an MCP. It's a win-win. So before we build anything, though, let's justify the architecture with some numbers. Why do we need MCP and TMLL? Again, why can't you paste the trace into your favorite AI? Let's call it Gemini this time. I did some calculation, and this is very important. I tried with Claude, and it decided to read the trace using Babel trace. And it started reading and reading and reading. I stopped it after 10 minutes of reading, and I saw that was about 2% through the trace. Reading one trace might cost you $1,000 in credits. We don't like that. We like not paying $1,000 in credits. With MCP and TMLL, the amount of tokens that it took were 2,000, because it basically said, open the trace, read the trace, post the results, and the AI was just the natural language interpreter between the person and the deterministic software. This is what I think is a very valuable future for tracing and for many other projects within Eclipse. We have a lot of brilliant business logic that we should be considering wrapping in this. So the subprocess wrapper adds about a second per call. It's completely dominated by the time of the LLM inference, at least. And even worse when I try it locally. So in my opinion, in terms of performance, the overhead is not bad in terms of time. And as we've mentioned earlier, I'm going to go back to the previous slide, it's not much in terms of memory because your context is tiny compared to before. And another thing that I really like is that the data is running deterministically on your computer or on a computer that you own. The trace data is high sensitivity. I can reconstitute a lot of things from there. You can figure out a lot of what people are doing, and you can even figure out their basic patterns and behaviors. This is not something that you should take lightly. It could be leaked. You can have the calculations done locally and have the LM just interpret the abstracted aggregated results. So this also, I would like to mention the free compute. It's not free. Nothing is free. It's running, in my example, on my laptop. And it's just that we already paid for the laptop. So it's already a fixed investment. We don't have to pay extra compute. So let's start. We want to create an MCP first. And this is not the only way to do it, but it's the way I like. We create a CLI for the tool. What's the advantage of this over just doing it over a dedicated bespoke API? Well, you get a CLI. People like CLIs. It works well with your CI also. So here is a normal Python CLI. It's argparse, subcommands, print, output. There's nothing special. It's wrapping the TMLL analysis. Now, I don't know if you can see well. I will bring the mouse here. TMLL client is run, then you get your experiment. You find your outputs. You do an anomaly detection. You find your anomalies, and then you print them. Easy peasy. Now you got to wrap this in an MCP. Now, I made the MCP fancier since last time, and the patch, you'll see it on GitHub. So it's actually now about 700 lines. I'm sorry for that mistake. But most of the work is adding the @ sign, MCP tool, and this is using FastMCP's library. And then you do a wrapper for detect anomalies, and the very important part, and I love this, if you want your MCP to behave well, comment your code. Explain the justification. Your comments become API because the MCP or the LLM gets the comments from FastMCP, and therefore, when you're doing this, you are making the project a lot less prone to mistakes. I'm not calling it hallucinations, but these are just mistakes. So here's the basic stack. You have on the very bottom, any agent that you want, any AI agent, be it Kiro, Gemini, Theia, Goose, and then you have your MCP server running. And so the AI agent will call the MCP server, which calls the CLI, and then the CLI calls the library. Now the library is resident in memory. Therefore, it's going to keep a state. It's not purely RESTful. And this is very good. You don't have to juggle contexts. So why am I suggesting this kind of architecture? I really want you to separate your concerns. You'll get a good CLI out of it, and MCP is relatively new. You're wrapping a CLI with this new tech. I suspect MCP is here to stay for a long time. It's already got a brilliant ecosystem. But I would like to make sure that if you want to wrap something else in it, you can, and that you're going to be on a hardened code path. And that is, for me, the most important part. One code path. You don't want to have many code paths to the same data, because then testing, debugging, and all that jazz becomes a nightmare. So we exposed 12 tools in MCP. They're very simple. Each maps to a CLI subcommand. It's, once again, we just @MCP tooled them. And another feature of MCP, and this is very important, please remember this, you can now progressively discover your tooling. Progressive discovery means that when you announce your capabilities, you announce a subset of your capabilities. For example, with tracing, the first thing we announce is, can you check if the trace server is up? That's all we announce. And because of that, until you use it, your context loses like 3 tokens. It's tiny. If anyone says that MCP is slow and eats your context, it's because they had a bad tool, not because the protocol was bad. Now, once you use it, then once you use your tool, then you'll progressively display other tools that are available, such as create an experiment or open an experiment. Because of this sequence, it actually forces the LLM into a specific UX, and that is very powerful, because at this point, you no longer are going to be prone to hallucinations, because the AI has no choice, the LLM has no choice but to pick the flow that you're giving. This is one of those cases where performance, security, and UX are perfectly aligned. So next up, MCP apps. This is one very hot feature. You might have seen it if you opened like ChatGPT, Gemini, Claude, and asked for airplane tickets, and you get these ads in your response. You get rich context returns. And it's basically, you could put an iframe in your AI return. You can put a PNG, and the AI will embed it directly in the response. So now, this is, for me, a very important part also. You're developing it. And now, I'm a pretty decent developer, but I never get it on the first shot. How do you debug this? Well, there are two tools that I really strongly recommend. Eclipse Theia and the MCP Inspector. Let's get into Theia first. So Theia offers this feature called the agent history. The agent history allows you to see the raw JSON that's coming in and out of your MCP. This allows you to figure out what worked, what didn't, with real-world data. I'm going to go back and forth here. The MCP Inspector gives you the ability to give fixed input and get fixed output. So this is a standalone web tool that allows you to connect to an MCP server, browse its tools, call them interactively. You don't use AI, you don't use tokens, you're testing that everything works. This is what you use once you think it works, to make sure that it works with real-world data and real-world prompts. Because when you're writing into your prompt of your AI, typically you're not controlling the entire prompt. You're controlling the last user chunk of your prompt. So this will allow you to see your entire history and see why it works on your machine but not in deployment. This is a game changer. So with these two tools, you actually can deploy things very fast. I was frankly shocked with how fast I was able to get things up and running. So let's look at some basic results. I made the one MCP server, and you saw how. And the server was working across multiple AI clients. I tried it across Goose, Hero, and of course Theia. And I wrote it once, and it worked everywhere. That's another feature that you want to have. So with Hero IDE, Hero calls the TMLL MCP, and the user asks in natural language what it wants. In this case, we don't see it in the screenshot, but it was plot the anomalies in CPU time for a given trace. And you can see on the bottom right here that you have the anomalies. I will use the mouse. The red dots are the anomalies. You basically limited your search scope from 10 seconds to 100 microseconds. By doing this, you can pinpoint your problem a lot faster. And I'm going to take a step back. When you're doing tracing, you have to first know if there's a problem. And then once you know if there's a problem, you have to find where the problem is, and then you identify it. You cannot identify a problem before knowing where it is. You cannot know where a problem is before knowing if there is a problem. This is a very logical sequence, but people tend to try to do everything at once. So here, we were able to find it. And this one also is very special for me. Here we have the Theia example, and I used the free tier of Google Gemini Flash 2.5. Why? Because it has billing that's transparent, and because it is the least performant free tier AI that I could find, and it still gave the great results. Now, Theia, you'll notice that the same query gave a different picture. And this is something that I would say is needed in the industry, that there's a kind of alignment between all the players on this, on what is being outputted. I like this one a bit more because you have a scroll bar and you have a decent sized picture. With this one, I actually had to take the magnifying glass to see what's going on. But, you know, this is my taste. So the very important part, and this, I need to remind you, is reading a 1 gigabyte trace file. It took, if you look up there, 5 requests. Oh, 5 requests and 85 kilo tokens to find the anomalies in this giant trace. This is savings, and it's also savings using unused compute on your laptop, keeping your data safe. And this is the kind of mindset that you should have, that MCP will allow your current legacy apps, and I don't mean legacy in a bad way. I mean that they are properly tested. You can use MCP to allow these applications to be AI-driven and accessing the power of the prompt. Okay. So, I was particularly fast. The main message is that making your AI tools, or making your tools AI accessible via MCP is very easy. It's surprisingly easy, to be honest. I have the patch up, and a little surprise for later. I do want to give some words of caution, like a bit of my war stories on it. There are a lot of poorly written MCPs out there, and they are giving the technology a not so great name. So don't let that color your view. I think you should really try out the tech and understand it before making your own judgment. There are other technologies out there like skills, and we can discuss that. But you know, a bad REST API design doesn't mean that HTTP is broken, and a suboptimal MCP design doesn't mean MCP is broken. So let's go through a few minor suggestions. If you are making an MCP, this kind of pattern, your library to a CLI, your CLI to an MCP, your MCP to the agent is very easy, very maintainable, very debuggable. If you make your MCP server, test it over several agents. Now, if you are 100% hardcore open source, first of all, thank you. Secondly, Eclipse Theia and Blox Goose are two excellent examples of AI agents that you can use to test both ends on the extremes. Progressive discovery is a game changer here. This not only improves the performance, but the security and the UX. When you do your MCP, you can test it locally, you can test it on a server. This is all not AI specific. This is basic computer architecture. AI didn't mean that architecture is deprecated. You need to architecture data flows. The bottleneck, it's pretty much never MCP. The LLM is going to be slow. You have to accept it and understand that it's a large payload and that the results are very high quality, typically, in terms of the UX and the look of feel. So you'll take that hit on performance, you'll have a 5-second latency, but you'll get a good result, or a happy result. Yeah. And main takeaway also, MCP is the protocol, not the product. So this is the summary of what I wanted to say. There's one little bit of good news, and I added this at the very end. This is the PR for the MCP. And as of last night, the maintainer of TMLL, who is not me, his name is Kavish Ahedi, and he is a beautiful, brilliant, and funny PhD candidate. Approved it, it was merged. This is in the wild and ready to be consumed right now. And I hope that we can have a discussion now on what your needs are and how we can help you with making your MCP designs. Thank you. Are there any questions? It's not on.
It's not, now it's on. Anyway, given if you had a CLI that has a proper help description, can you actually automate the generation of the MCP?
Yes, you can. Okay, the question. If you have a CLI that has the proper help, will you be able to automate MCP? The CLI that I did has a proper help. It did not automate the MCP, but it made it a lot more enriched. You still need to explicitly state what you want, and when you're doing progressive discovery, you need to explain the order of discovery. This does bring up another point that I forgot. When you're making your CLI, you need to make sure all your errors go to standard error, not standard out, because the MCP is expecting a JSON, and getting error messages in your JSON is the best way to make it break with really bad error messages. Thank you for reminding me of that part. Thomas, another question.
I have lots of questions.
Good. I have lots of voices, things to say.
You said it's expensive to actually analyze the traces with directly, right, with AI.
Yeah.
But isn't AI quite good at finding patterns? And is there research on whether that would be something good, even if it costs a lot?
So the question, would AI inference on trace data be something good? Now, there is a lot of research being done in that, and I am participating in a lot of research about that. So we can do this for a few hours, but the gist of it is that AI typically will have, the good ones will have a context of 1 million tokens. And a trace is billions of tokens, so it's 1,000 times larger, which means that you typically will read the full trace, compress, read, compress, read, compress, read, compress. Then at one point it's compressing, you have to compress again. You do that a few thousand times, which means that the context kind of grays out. Now, one statistical advantage is that typically you trace, and the crash is at the very end of the trace. And that is the most weighty item in your context. However, at that point, your context is so full that your AI will tend to hallucinate given current technology. This is something where we have deterministic means to get good results, and these deterministic means can give hundreds or even thousands of results, and you can use the AI to summarize those results. And that would be where I think the quick wins would be. Is that answering the question?
Yeah, more or less.
Okay.
Thanks for the great talk.
Thank you.
I really can confirm that MCP is awesome. I'm a maintainer of Sphinx Needs for traceability data. I've made the experience that MCP is great because you as a maintainer or developer can define what's the description of the features, and then the agent can decide, okay, how to use it. The problem is that if you as a maintainer does not know exactly how the feature gets used inside a project or something like this, then sometimes it gets misused by an agent. That's my experience, at least.
Oh, absolutely.
And then I have at least the possibility to tell via agent description, okay, use me the command line tool or interface, because then I can give a more specific description when to use it. Can you confirm this, or do we have some workarounds?
Okay, so the gist of it is that you list all the tools available, and then the agent uses it in a creative way which might not be considered right, or might be considered the opposite of right. Is that correct? Okay, so progressive discovery is a really good counter to that, where you only show the first step of your chain at first, your first tool, and then once that tool is called, the next tool is available. By doing this, you limit the error surface for the LLM and the agent. I've had very good success with that. Another way that I would recommend looking into it is there are other techs out there, such as Skills, but I can't recommend Skills for my problem space because Skills are non-deterministic compared to MCP. They give very good results, but sometimes they don't. Whereas MCP will always give the same result. It might not be good, but it's always the same. So you have to look at your problem. I hope that if there's one thing that's retained about this is that engineering is not dead by AI. Software engineering is not dead by AI. You're going to use these tools and we'll keep on trucking for a few years at least. But yeah, I can confirm everything you said. There are some tips and tricks that can minimize it, but I've never seen it completely eliminated. Also, the other problem is that it works on my machine it works on my model. This kind of confirms what you've experienced, right?
Thanks, yes.
Okay. So people, it means if you have MCP questions, you can go to him too. Are there any other questions or comments? If there's nothing else, the coffee is exceptional in OCX compared to EclipseCon. Thank you to whoever is sponsoring it.